right, then, happy Tuesday afternoon. We're going to conclude the sea level section or lesson today. And we're going to conclude that with a little bit different style than we've done before. We've been building up to get some information on what happens when sea level, as a result of sea level rise. Mechanisms are less important to us. Ultimately, for the next assignment, we're going to put you in charge of trying to plan for a city or some town, how you would respond or plan for potential sea level rise. So we're flipping the thing. We're not looking back in time, we're looking forward. The objective is to give us some experience dealing with a complex problem. And this one will be as complex as they get, I think. On Thursday, we'll start a new unit. That unit will actually talk about what is thought to be the most dramatic way to actually get a sea level rise of something on the order of 1 meter in 100 years. It's debated whether it will work or not, but that's okay. Before I get going any further, questions? All right. So to start with then, the meter rise, which we've talked about, that's our framework to worry about. It's prescribed. It turns out that there were articles for that time in the past when things are rising. There's oral legends and histories now being discovered or renamed, and here's an example of the folks that were subjected to sea level rise, so they kept talk about it. There are some people who would think that the biblical flood stories or myths or whatever you want to call them are part of that sea level rise. It may not be exactly that, but these stories, you know, they're like many things. They must have some element of truth, or you wouldn't keep seeing them again and again. And the archaeological record's a little bit skewed for this time period because most of where they would have been living is underwater now. So bring that home, and we're bored with that, right? I want to make a distinction between long-term events and, between events and long-term. Event might be a hurricane running through. A hurricane, because of the way the winds will work, will push the water up temporarily, and then it'll recede after the hurricane passes through. A long-term event, or what we are talking about, the sea level permanently rising, and if it's because of melting or decay of an ice sheet, it isn't going back. An event, you can go back to sort of whatever normal was. A longer-term exercise, you can't. So we would call that a short-term deviation of the normal versus a change of the baseline being the normal. That make perfect sense? Gentleman in the black shirt, comment on that, please. Nothing to comment on? Perfectly. Does the time matter?
Yes.
I mean, I like to think of tens of thousands of years. So is an event the same thing? If you don't have that perspective, is an event the same thing for me as it is for you?
Not necessarily. Because I guess an event on a larger time scale would be like the Younger Dryas,
Mm-hmm.
100 years or something.
Yeah, we could think of that as 1,400 years long, which is considerable in our framework, but it's as an event because it has a self-contained package. It went back to something normal than that. Okay, to bring this a little more concurrent, September last, the one that we just finished, is a complete oddball from a meteorological point of perspective. It's the hottest September on record. You see, there's two ways to look at this. Here's some sort of average temperature, the average. They've cleverly disguised this a little bit, but basically it starts in 1940 and goes to last year. And so this is the average temperature based on anomaly of the temperature change, half a degree and a full degree for each year. Boom, 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 boom. So you see that there's natural variations. So you could think of this as an event, but there's a long-term average. It didn't stay there. And then the average seems to be changing a little bit. And then there was September 23. This is global mean temperature. This is sum up the whole globe. And the question we really need to ask as a society, is that an event? Is that a one-shot deal? Or is that the new norm? If that's the new norm, that's a degree. The amount of energy involved in that is incomprehensible. So we need to decide whether that's an event, hopefully, or if it's the new norm. We got to start our planning last week. Another way to look at the same information, this graph here, this is the months, each individual month, the average for them, January to December, with July in the middle. So September, the month of September is right here. And what the colored bands are starting back in the 1950s. So it's the same data set plotted a different way. This just worried about September. This worries about the whole year. So if you take any one of these lines, you can see that it bounces around month to month, and every month's not the same. But you see that there's, and so if you follow the, you can't see the colors, but they basically go from the 1950s to the 2020s. So that's 70 years. And they start with the blues, and by and large, go to the oranges, and then the reds. So on average, that's what things have been going on, and that's, well, I didn't plot it too well here, but here's the 0 degree, here's the full degree, the scale's slightly different, but that's the warming that's taken place in the last 70 years, almost a degree of Celsius. Every year is different, every month's different, and they bounce around. The black line's a little different, right? What year is that? Is this year part of that trend?
In the black band, it just shows this huge temperature. So one of the long terms, the change of baseline.
Yeah, I mean, this is, I think this is illustrating the baseline. Out here, the year didn't started hotter than most of the 70 years in front of it, but not really an oddball necessarily. Come summertime, it went into uncharted territory. The temperature went into uncharted territory for this data set. And then September just kind of smacked the icing on the cake. So who knows what October, November, and December will bring. I mean, it's not a perfect way to look at it, but there's a lot of information in this graph. Shows the general trend, shows the noise, and it shows the oddball. Comments? Does this make you excited? Does this make you weary? Does it make you nervous? Does it make you upset? Does it inspire anything? Or are you saying, why are we talking about this? Be honest. Excuse me?
It's not really how you feel. I mean, I guess that, like, I can make people, like, nervous because 2023 is kind of going off of, like, the trends.
It's so far off the trend that there were a couple of people that just didn't believe it because, I mean, people who study it all the time said, we don't understand how this could be this far different. I mean, it's well instrumented. It's not a question of the measurements. I have a colleague who I discuss climate change with a lot, and I asked him if he'd seen these graphs, and he said no. When I showed him these, he was kind of spaced out. He was numbed by the magnitude of this kind of change. And this happened this year, this month. On a cheerier note, let's worry about further down the road when we're going to get drowned. All right. There's a sidetrack here, and the sidetrack is something called attribution science. You're seeing a lot in the newspaper about, okay, there's a hurricane, or there's multiple hurricanes, or there's a storm. Is that storm because of global warming? The short answer in most cases, it's not necessarily global warming. But attribution science is worried about, can we make that attribution? Can we attribute that to global warming? The problem is, back to the event versus the long-term baseline. And so a formal definition is a fraction of the attributable risk. It assesses the probability that an event happening in two different scenarios. So it's sort of a ratio. In other words, it might be a 1 in 10 chance it would happen normally, but there might be a 1 in 5 chance of it happening because of global warming. So if we go back to this, somebody's going to do an attribute study, and it's pretty complicated statistics, whether this is possible or is this because of global warming. They're going to find out this is global warming. You aren't going to get this kind of jump from the mean without something fundamentally changing. I don't think, I'm pretty sure. So this attribute science is really important, or it's a clever way of looking at things because we want to know, can we blame it on something? I think. Now, whether that's the most useful thing or not is different. It's the probability that the weather event would have occurred if not for climate change. You can talk about hurricanes, you can talk about snowstorms, you can talk about heat waves, you can talk about thunderstorms, you can talk about flooding. All of these meteorological things are pretty well documented and measured, and they would like to know, can we attribute such and such a flood? We're going to look at a hurricane. And you'll see it embedded in the newspapers. And then somebody will say, the scientists say that because of global warming, this is not likely to have happened. So this is an assessment, it's a statistical basis. How much can you attribute this to sort of global warming? It's very clever science. It's a little bit controversial because it's statistically based. If you want to dig into it more, there's plenty of sources about it. Attribution, do we want to attribute something? In other words, do we want to lay blame or responsibility for things? You know, I'm going to attribute you to the person that stole the cookies, right? Well, yeah, so I should give you full credit or not for the cookies, right? All right, so this is a statistical way to talk about climate. Is that a valid comparison to stealing cookies? Why not?
Stealing cookies is really like, you did that, but there's not always like a specific one explanation for why climate change.
Speak up just a tad, please.
There's a lot of different variables for what would affect climate change, not so many as to prove it's stealing.
That's an interesting point. The effort here is to eliminate those variables, to be able to constrain those variables enough that you can make a call. And again, it's a statistical thing. There's a 50% chance it could be attributed. It's not a surety because there, as you point out, so many things. But they're trying to take those into account. So it's the same, you might think of it as loaded dice, you know, you throw the dice, it's supposed to be random and you're always going to get sevens or whatever. Well, what would be the chances of 5 sevens in a row? Randomly, that's pretty rare. But if I had loaded dice, I could attribute it to the loaded dice showing up more frequently. That makes sense to you, sir, way in the back? Okay? And you ever attributed something to some cause that was beyond your control? Cookie jars or no? All right, so attribution science, that's a big deal. Extreme events. We talked about events being short-term things. I'm going to give a simplified statistical looking at things here. We're kind of brought up statistically, how many folks have had a statistical course? Okay, quite a few. And what's the underlying principle of the statistical course? What's the underlying principle of statistics in general?
Like the probability.
It's a probability. And so one of the things you could do is have a plot of the probability of the size of the flood, right? And so if you interpreted this graph, what would that probability look like? There's no numbers on here, but just pretend there's 1, 2, 3, 4, 5 or something.
Like
Size of the flood. So like here, this size flood has the most probability. This one has less. That one has less also, right? And in theory, this should be a symmetrical curve if the probability is a normal distribution. Most of weather is not a normal distribution. Most of climate's not a normal distribution. But nevertheless, the point of it, that's what you're, that and the fact that I can't draw a smooth curve is why this looks weird. But so the probability makes sort of sense, right? So if I have a large flood then, would I attribute that to climate change? No, I would just say it's a rare event. It's probable that's going to happen, but it's very rare probability. So far, so good. Lady in the blue. Where am I going to go next? What am I going to do in this one?
I guess how the probability can change over time.
The probability changes. We're assuming this probability is static. Is there any reason to assume that it's static? Maybe not. So exactly as she said, here's our original probability in black. And then for whatever reason, I've changed the probability. So what's the probability of that same flood in the red space, in the red probability space?
It's higher.
Pretty high. So in one case, it's very low. If I change the distribution, it could become the normal. Again, this is another way of looking at attribution science. This they would not attribute to global warming. This they would. It's normal. That same size flood. And what's the difference between C and D? Lady in black and blue there.
They look the same.
Yeah, they do, don't they? I don't think there's a big difference between the two. They look exactly the same. What I think I'm talking about is, this is our normal distribution. This is text to go with each one of these. And then the probability of a pre-shift extreme, shifted extreme. So they're really not any different. I think the first three get us across. All right. So there we go. What's the probability of September being? It's weird. It's extreme in the sense of, where would you pick the normal distribution for the yearly? Where would be the average year of this 70 years of record?
Like somewhere in the middle.
Yeah, they're going to make it zero just because that's a convenient way to do it. And the zero happens to be here. It's a little higher than we might think. So now is 2023 an extreme event, or is it the new normal?
Extreme.
It's still an extreme event, right? This is because they only go back to 1950. If they went back 100 years, these things would look totally bonkers. You'd have a lot of years down in here someplace. We won't do that today. All right, so far. Hurricane Ian, do you remember that one? Ian? I don't know. Let's see. It was a hurricane, though. We got that straight. It must have hit Florida because they're talking about it. The point was it was an event. It was a hurricane event. So we say it did a lot of destruction, took a lot of infrastructure out, drowned people out, blew away some roads, bridges and roads. And the fundamental question that people are asking, should we rebuild this? Would you argue to rebuild this road or not?
I would argue to put walls on either side of it.
You would argue to build it and then shield it.
Yeah.
You think the water wouldn't go around the walls?
Well, I mean, you just gotta wall it off so it's high enough.
So you got to put a wall over here and probably over here, and that means you got to disconnect the water from this particular bridge. Yeah, you're kind of rich, aren't you? how about rebuilding your home is in a hurricane, it gets wiped out. Should you just move back in there? I mean, it's just one hurricane. It hasn't hit in 100 years, but it hit you last year, so.
Yeah, I mean, like, I feel like realistically, it would be really difficult to like rehome people like in completely other places and just not house anybody in like a certain area because a hurricane hit one time.
So one time
But
seems like extreme.
yeah, but then if it like happens the next year and the next year.
Okay, so if you knew it was going to happen every year, you'd say no go. So 1 in 100, you don't worry about it. One every year, you worry about it. Where's the breakover point where you worry about it or don't worry about it? 1 in 10, 1 in 20, 1 in 30, 1 in 40. These are the kind of problems we have to wrestle with. Exactly the kind of problem we have to wrestle with. So, rebuild. Part of this concept has to do with a surge, the quotient of a surge with a hurricane. And the surge of a hurricane is a meteorological event. So this is a cross-section of land, the normal ocean, and then the swirly eye of the hurricane. Here's the center eye. It turns out because that hurricane is rotating around, there's a pressure difference in the air. And water, if you subject the center part of the hurricane to low pressure, which is what it is, the water will make a dome. It'll be sucked up enough that it matters. And so what you have is the storm's moving this way. Here's this dome of water, exaggerated to emphasize the point. And when the hurricane runs into it, the dome of water is higher than the normal water level. So this is the storm surge they keep talking about. Because of the hurricane winds rotating, one side of the hurricane gets smacked harder than the other side. Because one of the sides, the way it rotates, is pushing water also. So there's two effects here. Gentleman in the back, so far so good? Dome, wall of water coming at you in a hurricane. What do you want to do? Well, go to higher ground, right? Would you like to know how high the wall of water is? Okay, so here's where there are, guess what, predicted storm surge maps. So you can see for a particular area what they think a storm surge would be. Let's flip this around. We've got the storm surge coming in from this side now, and here's our tropical area. Here's the mean sea level, and here's normal tide. Problem is this tide goes back and forth like not twice a day, not quite twice a day. So all of a sudden it's high, low, high, low. Now the storm surge comes in, and that's 15 feet of water. So at high tide, there's going to be 17 feet of water smack the coast. What would happen at low tide? If storm surge of 17 feet, but tide is 2 feet lower than normal, how high would the storm surge be? Excuse me?
Like the wave is 17 feet high, which is higher than 15 surge. Is that the question?
Well, the surge, the amount that the air pressure is going to push is 15 feet. We got two cases. We could do it at high tide, where water's 2 feet high, or low tide, where it's 2 feet lower. So the 15 feet, if it's at high tide, gives us a total of 17 feet. Bad news. How about if it was at low tide?
The surge will
That would be down here someplace. So the 15 feet would be,
it will flow down to the right.
doesn't necessarily flow to the right. The surge is still going to come, but it's not going to be as high against the land because the tide's already 2 feet out. So it's coming out over 2 feet lower, the 15 feet. So here's where they're really panicking about what time the tide is. And so you can get a storm that gives you small effects versus big effects, just depending on how it happened to land relative to the tide. Tides are fairly well predictable things. There's not 2 a day. There's something like an hour. There's one in, I should know this. They're every 11 hours and 45 minutes, I think. That doesn't add up, right? So anyway, so there's a surge, and we can worry about that. So this is info if you were trying to plan for something. The gentleman in the black cap. If I wanted to plan for something, do I need to worry about this effect? Plan for sea level rise. How would I do that?
If you were still in a residential area, it would be a matter of like looking at elevation, as far as like the coastlines and things like that.
I'm gonna worry about the elevation a lot, aren't I? Now, each storm is gonna have a different, first of all, you gotta have a storm go through there. And hurricanes don't always go back to the same place, right? Second of all, the strength of the hurricane matters. Third of all, the chance of where it happens in the tide matters. So is that easy to accommodate? How should we accommodate for it?
Yeah, because we've seen, hurricanes absolutely devastate places like the Katrina with this New Orleans or other cities like that. So it's important to still prepare for this kind of things, but also like you said too, it's not likely to hit the exact same spot twice.
It's not likely to hit the same spot, may not be the same storm surge, may not be the same tide phase. So there's going to be a lot of possibilities. And it's also the thing of, if you knew it was going to happen every year, it's one thing. If it was only once in 100 years, it's a totally different. So how many variables have we got that we got to worry about now? 1, 5, 20? A lot, okay. Wouldn't that make a fun homework exercise? Yes, I thought you would agree. Okay, so in the end, there are 3 routes that we can talk about for sea level changes. This isn't the adapt, evolve, or die. This is the adapt, figure out how you're going to survive under higher sea levels. Not just an average sea level higher, but the storm impacts. That's going to be the gnarly thing. We can try to mitigate. The gentleman who suggested building a bridge or dam on either side of the road, that was an attempt to mitigate the effect of sea level against that bridge. Adapt is just suck it up and build a bigger house, mitigate it, make it less severe or intense, broke out the water. Or we can move. This is the equivalent of dying. So how do you decide whether you should, where is your confidence level between move or try to spend some money? That's basically what this is saying. Live with it, try to attenuate it. Just say, I'm going to get a hurricane, I don't care. I want to do something about it. Expensive. Give it up entirely, go someplace else. Questions on that?
Yeah.
Sir?
Like the adapt, I think adapt and the mitigate is quite the same.
I'm sorry?
I think that adapt and the mitigate is quite the same.
Adapt?
Yeah, they both do some change to mitigate the situation, to bad situation.
I think the difference would be adapt is you personally would adapt and just say, I'm gonna expect that I get a hurricane once every 5 years and I'll just live with it and I'll take the risk.
Like doing nothing reaction.
Do nothing, yeah. I'm going to either do nothing or I'm going to potentially try to reduce my impact by saying I'm going to get a car and drive away every time the hurricane comes in. So these are sort of changed to be able to survive under those conditions. This is actually trying to build a road. This is trying to build an infrastructure. This is trying to stop the hurricane, which you can't actually do. But conceivably, if you could figure out a way to stop hurricanes, that would be a mitigation strategy.
Like I will stay here, but I will like build a bridge, build a floating bridge to deal with the hurricane.
Okay, so if you build a floating bridge, so it doesn't, so it comes against the, water comes in, it doesn't care, right?
Floating, I don't know if that work to build like a boat. If
Right,
the,
sure.
If the sea level goes down, it does normally, but if sea level goes rise, it just float it.
It'll float under certain conditions, sure, it'll float,
Float on the surface of the sea.
right?
Yeah, the road of the floating bridge is always dry.
So is that a mitigation strategy then?
Maybe.
That would be a mitigation, because you're trying to do something actively to make it less severe. Whether that it would actually work or not is a different question, but that's, I think, does that clarify this? Does that help?
Yeah, I'm
Clarif-
with you.
Okay, good. Any other comments? We're sort of winding down, and we're winding down because we want to talk about long-term, which is the Shefton baseline. Plus, we need to worry about the events. And these are the philosophical questions. As you tackle the specific tasks in front of you for this assignment, I would try to break it down this way. You might say, I'm going to, my plan, I'm going to ask for a plan, but my plan is only going to worry about the long-term aspect. So I'm not going to worry about the extreme events, I'm only going to worry about the long-term trend. Or I'm more worried about the long-term event because I get hammered all the time. Therefore, this plan helps attack the extreme events. So state which strategy you're taking. It'll help reduce the number of lots of variables down to half a lots, which still is a lot, but okay. How do we figure out all the impacts? We can't, but you looked at the impacts from the maps, the coastal maps. I didn't say explicitly, but I'm going to send you back to one of the towns that you already did, the low-lying town. You've got some familiarity of that. So you're going to be the town manager for that town, whatever it was. You can shift if you think you've got a mess. But how do you figure out what the impacts are? Well, you've looked at a map, you've looked at some predictions. You can list those. Do I expect you to list all of them? No. A couple examples would be great. Then how do we decide what to do about it? I'm asking you to develop a plan. Not a plan for a plan, but a plan. The last one has to do with, it's a wonderful thing to build a plan. It's another to pay for it. Who's going to pay for it? The floating bridge might be a wonderful solution. They're not cheap. Otherwise, they build them all over the place, and then they wouldn't have to worry about them. So is it, after we've got a plan, is it practical? I'm not asking you to be super critical about the practicalityness of this, because we're not going to do any economic analysis on it. But I want you to be aware that those considerations would come in at some point. I think that's fair. I think it's fair to ask that question. If it's, you know, horridly expensive. It's about probability. The same thing with floods. Floods are supposedly the high water level every 2.5 years, or 2.3 years. And so you can figure out what that level is on a river, and you can say, we have a zoning code, so you can't build a house in that flood zone. And there's a whole network called FEMA that's worried about that. Okay, it's a probability thing. I was developing a piece of property in Maine, and they told me I was in the flood zone. Being a geologist, and I was on a lake, I wasn't in the flood zone. But nevertheless, because there was a regulation that says I was in the flood zone, I had to do something with the insurance company. So that assessment is an attempt to codify something for the greater good. We don't want to pay for everybody's flooding event, because we know flooding's happened. So we try to put a pool of insurance together or something that allows you to distribute the cost. Can we do the same thing for sea level rise? Much different scale than the flooding on a river, on a small river. Right? Are we ready? Are we ready? Do we have any questions? These are just to get another level of confusion in there. We could build a floating bridge that would survive the next hurricane, but that would be it. For the extra, the extra twice as much or something, we could build a structure that would work for the long term. What do we want to design our plan to do? Well, I said before, and I said this is a different way of saying it, the long term or the exceptional? Should we rebuild or relocate? Got $1 billion. Is it better to rebuild with $1 billion or move people along? This is all opinions. It's time you started thinking about these kinds of opinions. Should we allocate resources to protecting areas with a higher net worth based on some financial economic consideration, or areas that have larger populations? You want to put your money where a bunch of people are, or where there's expensive infrastructure? Who's going to pay? And at some level, I'm asking you this question, who's going to pay? I'd like you to think, do you think it's more appropriate for individuals to kick into the kitty of sea level rise, the local government, the state governments, or the feds? The UN's not going to touch this. They've got a global sea level rise to worry about. Okay. Let's see. The lady in white, between the lady in the red and white and the black. Which question do you think you're going to ponder on? Which one's going to be most perplexing for you?
Probably the second one, like rebuilding or
Rebuilding or relocating. Which is going to be the easiest for you to decide? Should have asked that first, right?
relocating seems the easiest, but then once you think about it, it's like
Right. It's got downstream effects, right? Sad news, none of these decisions have no downstream effects. All right. Which question do you think is going to be most difficult for you to deal with, to come to terms with?
The last one.
This one? Who pays for it?
Should talk about government, so
Well, government's kind of a collective, larger thing. So is it your town, or is it your state or province, or is it the feds? You know, the feds have a very active flood insurance thing for rivers, not for the ocean as much. You're gonna, I'm asking you to take a town, and so should the town pay for it out of themselves? Should they tax the individuals? Should they petition their state legislature or the next branch of government up, or should they get money out of the feds? Okay, I mean, they're all choices. Here's the tool that we looked at. I suggest that you probably would, again, I'm going to assign you to go back to the low sloping one. Go back there, relook at, based on any comments that were made for evaluations, and now that you know that you want to focus a little more on that particular town or that part of the town. Doesn't have to be the whole town necessarily, but I'm just putting up the front manager of it. So go back to that. This is get you the good one, and now we're going to try to mitigate or reduce the impacts of sea level change. All right, so that's what's due for Thursday. I've broken it down into little pieces. Pick a location. I encourage you to use the same location so you can get 2 for 1 out of it. Suggest a plan for that local agency. City of Malibu, wherever. Some of them are smaller towns. Now we're really talking about the 1 level of sea level rise in 100 years. That's the long-term trend. We're going to try to deal with that long-term trend. Window dressing, or the icing on the cake, is what do we do about the hurricane events? Tell me what the place is again. General, this stuff is almost the same, but it should be a little more detailed by and large than we did for the other time. Now tell me whether your plan is A or B, long-term, or I'm worried more about events. Are we trying to force people to adapt? We'll build a better road so they can escape every time I turn the events. So I'm going to build a better road so people can escape that. Or I'm going to mitigate it. I'm going to build the bridge or the boat landing, or I'm going to relocate. Some towns should bail out. Some towns maybe not. Hardest one. Tell me exactly what you're going to put 1 or 2 steps in it. I don't want a comprehensive plan. I just want something that'll working. Shows you go through the whole thought exercise. How are you going to pay for it? And then separate from that is our standard. Tell me what we learned in this lesson, what you learned, or what you think about this lesson. Those 20 pointers come in handy. Oh, there's a bonus here about attribution science. Would you want to use that in your, or is that a totally separate issue? They're going to come out and say, you're going to get more hurricanes. Oh, how many more? In Newport News or wherever it is. How many more? Well, I believe that science. I would encourage you to hang around a little bit and try to form, if you're fuzzy about this, hang around, we can talk about it. If it's crystal clear what you want to do, I'll see you on Thursday. If you want some nudging, I can do that.